Welcome to Big Data Brews today with Hortonworks CTO Ari Zilka. Hey, welcome.
Thank you.
Can you introduce the beer you like here? It says Czech style Pilsner. It's very European.
It's a Gordon Biersch Pilsner. I really like Pilsner Urquell.
From now we're friends.
Czech Republic. So,
yeah, good. I love that. It's
at least when it's on draft in the Czech Republic, in Prague.
Yeah. You travel there a lot.
Yeah, I love that city.
Oh, it's beautiful.
There's the Xbox One has this driving game, Forza Motorsport, and they have a track which is the streets of Prague, and I've been playing it, and it just makes me want to go back to Prague right now.
Do you go over the bridge as well into the castle up?
Oh yeah.
In the game?
Yes.
Oh, okay. Yes. Wow, nice. There's cool technology in Prague. A bunch of friends there. So, can you introduce yourself? What's your history? What are you doing? And besides drinking Czech style beer?
Shall I actually drink?
Yeah, please. and if you, I will have a porter today. So.
Okay. Anchor Steam.
Yeah.
Which Anchor Steam, interestingly enough, is bottled over in South of Market in San Francisco, about 2 blocks from the company I founded, Terracotta.
Oh, cool. So that's a good intro into into your history. So what did you do before Hortonworks?
So I'm CTO at Hortonworks now. I started out at Hortonworks as Chief Products Officer.
Okay.
Transitioned into the CTO role recently. Always did part of the CTO role. I don't know what a Chief Products Officer is, but we used to divide CTO into outbound and inbound. And I was outbound focused on customers. Now I'm both outbound and inbound focused on product and roadmap and features. Before Hortonworks, I did the CTO role for Terracotta, the exact same thing, outbound and inbound. So when I say outbound, yes, I've done talks. I've stood alongside Rod Johnson at Spring One and things like that, and got the Duke's Choice Award from James Gosling at Java 1 for what the team did at Terracotta. But more importantly is I spend most of my time with customers. So I'm always doing it's not a word, but our CEO calls it solution architecting. And architecting is not a word, but I don't know what else to call it. So basically solutioning with customers. Give me your problem domain, give me what you've thought about, what you've researched so far, and we'll go to a whiteboard first, we'll sketch it all out, we'll deal with all your corner cases, edge cases, complexities, volume, variety, velocity, even though I hate the 3 Vs, and any marketing spiel like that. But go through all of that stuff, nail it down, then start building proofs of concept, project plans to prove to ourselves this architecture will work. I'll checkpoint with you. That's the outbound side of my role. The inbound side of my role is come back into the organization, engineering and product management, representing all that myriad set of use cases, and say, Hive needs to do this next. Nobody's using Pig, everybody's using Pig, things like that.
Yeah. Well, cheers and congratulations to your new role.
Cheers, thank you.
Or title. So let me double click on the history. So Terracotta was a pretty cool backend for kind of the distributed environment in Java world. I happen to know. Yeah.
Cool.
But
actually, as I go around in Hortonworks, I find most people know Terracotta. I just wish more people had written checks for the software.
So, but let's start a little bit there. And I think you also was a CTO at Walmart.
Chief architect
at
Walmart.com.
Oh, okay.
Yeah.
So you're in the Bay Area since quite a while.
Yeah.
Okay.
Did
you grow up here?
No, I went to Cal.
Okay.
And never left.
Okay, well, it's hard to leave, right?
Yes.
So what did Terracotta do before we jump into the big data? I mean, this is big data, Terracotta, yeah?
Terracotta is big, fast data, is what we used to call it.
Yeah, in distributed environment. So.
Well, I don't know if I'm allowed to say it, but I'm not at Terracotta anymore, so I don't care. But PayPal, for example, PayPal.com is powered by Terracotta. Yeah. And I think that's 40 terabytes of purchase histories in memory to figure out fraud detection. And without going into detail, it is big data. It's big in-memory data.
Yeah, okay.
And that's why their products now are called big memory. But essentially what Terracotta does is it's a 2-tier application level cache that a developer's in charge of. So a developer uses it, wants objects from some data store, and doesn't really want to know when they're getting them from the data store or when they're getting them from local memory. And then they want to deal with the fact that their application is actually deployed to multiple instances. And they don't want to deal with consistency across threads and across, I call it space and time. So my data is changing. I need to deal with the freshness of that data / correctness of that data. And I need to deal with the latency of access to that data. So I'll basically stick a Terracotta server in front of my data store, and then I'll wire all my applications onto Terracotta. And this is sort of a misnomer, because you'll read around the database and put data into Terracotta. You won't read through Terracotta, but you get a cache here, you get a shared cache down here. This is actually scaled out, partitioned and replicated. So RAID 0 + 1 in software, in memory. And then it offloads this guy tremendously. So anything I change here is visible here, is visible here. I have dials or a continuum to be able to set consistency levels, read consistency, read-write consistency, XA compliance, and all that kind of stuff. So what this allowed the average application to do is store terabytes in memory at 1 millisecond latency access time. Worst case, 10 milliseconds down to Terracotta.
And you already said objects made me really excited because as a big friend of SQL, so we obviously we did a bunch of Spring, or I did a bunch of Spring applications with Hibernate and then EH cache and those kind of things. And you guys are kind of the distributed version of that, but you always stored Java objects.
Yes.
Yeah, okay. How did you deal with the whole serialization? Did you do reflection on, how did you compress the objects?
So there are two incarnations of Terracotta. The first incarnation didn't go, and we disassembled applications at the bytecode layer and found when bytecodes were editing field level values. So we had a zero marshalling system. So we weaved ourselves into an application and watched it make changes, and you would grab a lock, meaning a synchronizer barrier, that would start a journal in your local thread. We'd keep track of everything you changed. When you released the lock, we'd flush the change. So we were memory model consistent but transparent with pseudo no marshalling. It didn't go because most applications weren't thread safe. They weren't actually doing things correctly. We knew it. We just thought that our tools could help them find their thread safety issues, and it was just too hard for them to clean up their apps. And so we went to a straight serialization on put, deserialization on get kind of model, with the caveat that you want to not use Java serialization. It's space inefficient. It's time inefficient. Totally. Secondly, you had a problem. You had an opportunity to optimize that you could store a deserialized cached form in the application.
So you
didn't deserialize every time you got. You deserialized the first time you got on this node, or that.
So did you have your own serialization interface then, if you didn't use the Java one?
No,
you overwrite the serializer.
Yeah.
I did this once for Hadoop. It wasn't very popular because, back then we discussed with Doug, should we have writables or should we have serializables? And I was a big fan of hey, Java is serializable. We just have to overwrite the serializer. But obviously, if you just use Java serialization, it's just incredible slow, right? And
but it's incredibly intuitive. The Java devs know what to do with transients.
And then we ended up with writables, and then nobody ever, that was one of the biggest, or is still one of the biggest problems in Hadoop, right? People I have that string writable object, let me put that into a local variable and get access to it a little later, and they're like, why did the string change? Right? So because you obviously recycle the object all the time. Anyhow, but interesting. Good. So
and what's interesting about all of this, it's kind of funny because we were working on Project Stinger at Hortonworks and trying to make Hive much faster. And one of the things we came across was the Java system class loader is god-awful slow. For the Hadoop core jars, they're so big that it takes somewhere between a half a second and 2.5 seconds to just start up a JVM with Hadoop's proxy classes and everything wired in. And so we had teams start to write our own class serializers, and we called it a Hadoop shared object. And so we could pass classes around and
And
share
recycle
them in
them.
the cluster, recycle them, but load them faster into the system. And we got down to like a 40 millisecond JVM startup time,
Nice.
with the only catch that you had to override the system class loader, which I told the team, hey, I've played this game before. People
Yeah,
don't
was
do
there,
it.
done that. I did a lot of...
No one wants to overload the system class loader.
Yeah, it's a little sketchy. But, you know, on the other hand side, you have your Hadoop cluster, and you usually, in that GVM, don't run anything else, right? But yeah, I had a lot of fun with class loading when I worked for JBoss.
Yeah.
Right? So good old times, right?
Yeah.
And overriding and making sure that log4j and different version and different EGB jars,
Jar
blah, blah,
jar,
blah,
yeah.
all that good stuff. Great. So tell me a little bit about your work at Hortonworks. What's the most exciting project you guys working on right now?
The most exciting stuff we're working on right now is inside Project Stinger. There's two exciting things. I'm going to erase this diagram.
Yeah.
Or try to.
But, you know, it's style if you have multiple layers. Yeah.
Yeah. So inside Project Stinger, there's two really exciting things we're doing. One is on the storage and access to data layer. It's ORC files and vectorization. Super exciting, and will help anyone.
That's Owen's child, yeah.
Owen, actually, no one.
No,
he never wants to admit it, but ORC is called optimized RC. In reality, it's Owen's RC.
okay.
But he's not arrogant, so he doesn't.
No,
like
he's
that.
not. No. I know Owen's very well. Yeah.
But so on the storage side, it's ORC files and vectorization on top of those ORC files. And then on the factoring side, on the architecture side, it's projects Tez and YARN.
So now Docutting would come in and say, "Org, you know, I can do that much better with
Parquet."
So, you know, jump on that.
Sure. So at the end of the day, ORC is a format contributed by Microsoft's super geniuses inside the PDW team. These are actually guys who have spent, you know, in some cases 30 plus years in data storage formats for relational workloads. ORC has some things that are just superior to anything else on the Hadoop platform right now.
Like
block level indexes.
Okay.
And type aware indexes. So it's a columnar format. I'm not going to bother to sketch up what maybe I should.
Yeah.
But I mean, if you have a block like this, you really want to store all column 1 values, and then all column 2 values, and then all column 3 values. So typically, you call this a columnar store.
Yeah.
Some advantages we get, and most columnar stores, all columnar stores do that. That's not interesting. Advantages you get is you can take column 1 and compress it.
Sure.
Because now you
Most
have
likely
more,
better compression.
most likely better compression, because you have more consistency across value space.
Yeah, and luckily, very frequently, you know, Hadoop files are sorted, so even better compression.
Exactly.
Yeah.
Like you take a web log, and this would be IP address, this would be access port, this would be browser type, right? And browser type is going to be what now? It's going to be
1 or 2
it's
or
going to
3
be
or 5.
Chrome or what is it called? Chrome or Safari or Internet Explorer, and that's it.
No Internet Explorer anymore.
So what we're columnar, and we can actually handle columns where the individual record sizes are quite large. We're type aware, which means you tell us if this is an int or some kind of numeric value or a long. You tell us that this is a string, and then we start doing things that are type aware. So we're SQL and Java type compliant, which is superior to anything else. But then we have an index as part of each block.
Okay.
And so they're stored contiguously.
Even navigate the block much faster.
Yeah.
How big is the block size?
It's configurable, but a good block size is like a gigabyte.
Okay.
Yeah.
Okay. Well, then it makes sense to have a index in front.
Yeah. So for example, a string index would be a dictionary.
Right.
So we dictionary encode strings, and we write all the unique strings up in the index. We compress them down, and then we write an integer lookup.
Yeah.
So
makes sense.
If you have things like URLs, they repeat a lot, and the URLs are actually going to just be URL 1, URL 17, URL 22, URL 33. Integers, we're going to have min, max, average, things like that.
Per block.
Per block.
Okay.
Date, we're going to have start date, end date.
Yeah. Okay.
And so
and it makes it small and really fast.
We find that we go, and then what you can do then is you can basically use the index to skip a block.
Yeah.
So when you're doing what? When you're doing filters and aggregations, you want to basically say there's a where clause, there's a query predicate. I can apply the query predicate to the index.
Right. And you don't even need to like...
Right. And I don't even need to hydrate the rows or columns at all.
So a row is the slow part, the deserialization, the inspection.
If this is row 1, this is row 2, this is row 3, vectorization is the classic Java loop. With my, with my connection, I get a result set. And while result set dot has next, then result set dot field 1 dot field 2 dot field 3 next result. In a while loop, that while loop kills performance because you're iterating through a result set and you're paging data from various large RAM pools into processor L1 cache.
Right.
And what we're doing in vectorization is saying, leave this block dehydrated, flattened, unmarshaled as a block. You can look inside the index as much as you need to. And when you do pass it across the block, vectorize the query predicate. So turn the query predicate into scalars and then pass it across this as a mask. So you're basically looking at a giant set of ones and zeros.
And you basically just
and you're saying, I'm looking for the following pattern, 1011. And it says there is 1011. And then you say, oh, well, I want 1011 this way. And it says, okay, I see it right here. It's row 23.
Yeah.
And then you pull out row 23.
And then you even don't need to
So I'm moving a gigabyte at a time through the data. Obviously, L1 caches are on the order of megabytes. So to move a gigabyte into a megabyte L1 cache or a 16 meg L1 cache will take you hundreds of clock cycles or a few thousand clock cycles, which means it'll be done in under a second.
Yeah.
And we literally found a single laptop could manage a terabyte search in under like 2 seconds.
Nice.
With vectorization. So the ORC file is tied to the vectorization, and the ORC file is tied to a lot of stuff we intend to provide to technologies like Datamir on top of us, which is this global level index. Because if we take these indexes, you can use them now to show people ontologies about their data. So I have a column, I know its name, I know its type, and I know its value range. Like I can bring the dictionary forward into Datamir. I can bring the integer min-max data timestamp values into Datamir, and that becomes dimension data or ontological data that's very interesting to the end user. Even though the system doesn't know what it is, it's very interesting to the end user. I can use it to speed up searches because I can skip blocks. So really what we're talking about is take that index, centralize it to the entire table space or data set, if you will, and then proffer that up to anyone who wants it. Now you can build systems that actually service queries without ever looking at a record at all.
So
and by the way, you paid no price to compute it except on ingest. You laid out
that will be my next question.
Price.
That will be my question on how is that impacting write performance?
So you're packing a gigabyte block, you're consuming some extra memory, and you're type aware, so you're marshalling the types on write down into disk. Our write performance for an ORC file needs to get better. But right now, we have tuned it, so it's faster, I think, to write an ORC file than an RC file, for example.
Okay. Well,
and an RC...
That wasn't great. Right? It's always the question of who you perform with, right?
Yeah.
RC file wasn't great.
Well, we've benchmarked ORC file writing against anything we can get our hands on. We find the best things out there we're competitive with. Well, I don't even want to name specifics, but I don't see a problem I see a problem in performance relative to an absolute number I'd like us to get to. So we can write tens of megabytes a second across a cluster. I want to write hundreds of megabytes a second, but no one is writing that fast right now. So.
Let's zoom a little bit out of this. This was really great and helpful. Let's zoom a little bit out. So that will be part of, you said, Stinger.
This is out in public GA.
Okay, Hadoop. Good. And basically everybody can write against that then.
Yeah. In fact, that's where YARN and Tez come in. I'll let you zoom out in a second, but no one knows about ORC except us and our customers, our paid customers. and are open source followers of Hortonworks platform as something that's part of the Hadoop community solution space. What I'd like the whole world to do is, since ORC is in the open domain, truly open in Apache, gifted away, we need to build all the tooling around it. People need to be able to ingest into ORC, which is not obvious. Like, obviously, I don't want to write one record into ORC. I want to write a whole block into ORC. So people need block writers into ORC that buffer up and guarantee delivery, perhaps through Storm and Kafka or something like that. But you need a buffered block writer for ORC. Then you need to be able to assemble tools that consume ORC data efficiently. Not just Hive itself, but what if I want to write my own system that has nothing to do with SQL, but still completely dependent on ORC, vectorization, and block level indexing, right? I'd like to skip blocks and have query predicate push down, project my query onto my data as data mirror or as a custom application. How do I do that?
Yeah.
And the answer is Tez and YARN and all this other stuff.
We do a bunch of the indexing stuff we already do on our system, but not on that low level, right? Since we own data ingestion, we already do all this. And we have in the next version actually really cool stuff coming up. Anyhow, well, cheers. Cheers on org.
Thank you.
And let's make a quick break. And then we continue with the next session and talking a little bit more about the Hortonworks ecosystem and what else you guys doing.
Okay, sounds good.